بسم الله الرحمن الرحيم. سيدات والسادة المشاركين في المؤتمر الدولي الأول للأبحاث المتقدمة في العلوم الصرفة والتطبيقية لكلية العلوم جامعة المثنى، السلام عليكم ورحمة الله وبركاته. في هذا السيمينار نستعرض أهم ما جاء في البحث الموسوم Design, Synthesis and Evaluation in Vitro Antibacterial Activity of some new 1,2,3 Triazole derivatives by علي شاكر رزاق, حوراء عبد الكاظم مزيد and corresponding author رياض جليل ناهي. What we are talking about today, a brief introduction of heterocyclic chemistry, the aims of this work, results and discussion, and antibacterial activity. Heterocyclic chemistry is an interesting branch of organic chemistry, which is accounting for about 1/3 of modern publications. In addition, more than half of organic compounds that are present globally are heterocyclic compounds. Heterocycles are aromatic systems or partially fully saturated cyclic compounds in which one or more non-carbon atoms are presented in the cyclic system. Oxygen, nitrogen, and sulfur are the most common heteroatoms. Heterocyclic compounds have medicinal and biological activities such as antifungal, antibacterial, antimicrobial, and antioxidant activities. We aimed in this study to synthesize a combination of 1,2,3-triazole and 1,3,4-thiazole in one molecular framework, and then study the antibacterial activity of the synthesized compounds. In this slide, we observe the general scheme of the synthetic pathway of the target compounds. We started with aromatic amines as starting materials, reacting with sodium azide and with ethyl acetoacetate to synthesize 1,2,3-triazole ester derivatives, the latter compounds refluxing with hydrazine hydrate to give the important key material in our synthetic series, which is acid hydrazide. To synthesize hydrazine 1-carbothioamide derivatives, also called thiosemi-carbazide, a mixture of acid hydrazide and commercial available phenyl isothiocyanate were refluxing in ethanol to give thiosemi-carbazide derivatives, as shown in scheme 2. Many techniques were used to verify the formation of the synthesized compounds. FTIR, proton NMR, carbon-13 NMR spectroscopies, and GC-mass spectrometry. In FTIR, comparison spectra of acid hydrazide and thiosemi-carbazide derivatives, which indicate the disappearance of primary amine peaks at approximately 3,200 cm -1. In proton NMR spectra of thiosemi-carbazide indicate shifting of primary amines protons to approximately 10 ppm due to a new bonding with thione group, as shown in figure 1 and 2. GC-mass spectrometry also verified the formation of thiosemi-carbazide derivatives, which showed that the calculated values of the ratio of M over Z being almost identical to the measured values, as shown in figure 3. Last but not least, the synthesis of final compounds, which is a combination of two heterocyclic rings in one molecular framework by cyclization of thiosemi-carbazide derivatives with concentrated sulfuric acid to give the target 1,2,3-triazole containing 1,3,4-thiazole ring, as shown in this scheme number 3. FTIR, NMR spectroscopies, and mass spectrometry were used to verify the formation of thiazole derivatives. FTIR spectra indicate the disappearance of carbonyl stretching peaks at approximately 1,700 cm -1. In proton NMR, we noticed the disappearance of secondary amine protons at 10 ppm due to cyclization of the intermediate thiazide carbazide as shown in figure 4 and 5. Carbon-13 NMR and mass spectrometry were also verified the formation of the final 1,2,1,3,4 thiadiazole derivatives as shown in figure 6 and figure 7. After obtaining the title compounds, we focused our efforts on screening the ability of inhibition the group of bacterial strains using well diffusion method against 4 types of bacteria, 3 negative, which are H. pylori, Klebsiella pneumoniae, and E. coli, and 1 positive Staph aureus bacterial strain, and using tetracycline as standard drug and dimethyl sulfoxide as negative control. Table number 1 shows the inhibition zone of the target compounds against the 4 bacterial strains. The results indicate a good inhibition activity against Klebsiella pneumoniae and Staph aureus, and weak to moderate activity against H. pylori and E. coli, as shown in Table 1. These some examples of the inhibition ability against Klebsiella pneumoniae and Staphylococcus aureus of the synthesized compounds. Thank you for your attention ودمتم في رعاية الله وحفظه والسلام عليكم ورحمة الله وبركاته.